Alright, so continuing right triangle trig here, 6.2. We're on example 3. So I need to solve triangle ABC. So there's C is always hypotenuse. And if that's C, then that's 90 degrees down there because that's angle C. We said A is 12.3, so there's A. So I don't know what angle A is. And B, which would be side B right here, is 31.6. I don't know what angle B is. So to solve triangle, it means solve for all the parts. The easiest one that I know to find right now is actually not the angles. The easiest one I know of to find would be this side length right here, and the reason why it would be the easiest is because we could do the Pythagorean Theorem to figure it out. But if we wanted to find those angles, we'd have to do SOHCAHTOA. So sine of this area right here, sine is opposite, which is 12.3 over C. Well, I don't know C, so it doesn't help me to use that one yet. So move on to something else. Cosine is adjacent over hypotenuse, which would be 31.6 over C. Don't know both, so that won't help. So cosine doesn't work right now either. Tangent would be opposite over adjacent. So that one works. So because it works, it's because we have numbers in both the top and the bottom. But here is what you need to keep in mind. To solve this, it's called second tangent because we don't know what the angle is. We're trying to find the angle measure. Whenever you're trying to find an angle measure, it's -1. So that's why it's second tangent. We'll give you that tan of -1. So second tangent will be 12.3 over 31.6. So second tan of that, we end up getting 21.3 degrees. So alpha is 21.3 degrees. So from there, now I can do the Pythagorean theorem to solve C, and I can also know that a triangle is 180 degrees, so I can use that information to solve for B. So B is 180 minus 90 minus 21.3, because I know a triangle is 180 degrees, so I take those away. It gives me 68.7 degrees for beta. And like I said, I can do the Pythagorean theorem. I know that this is A and this is B, so it's 12.3 squared plus 31.6 squared. And that equals C squared. So all of those added together is 1149.85, and that equals C squared. So C squared, I square root C on both sides to get C all by itself. So when I square root on both sides, you end up getting plus or minus 33.9, but you can't have a negative length, so it's positive 33.9 as your answer for C. Those are your three parts. Angle of elevation is your angle of sight. So here I am looking at something straight on. So going up, that's the angle of elevation. From level, looking straight, and then up, that's your angle of elevation. Okay, looking down, however, it's going to be your angle of depression, so you understand what we're talking about. When you're depressed, you hang your head low, so that's your angle going down. Angle of elevation is going up, so keep that in mind. So example 4, from a point on level ground, 135 feet from the base of a tower. The angle of elevation at the top is 47 degrees, 20 minutes. Approximate the height. So here's a point on level ground, 135 feet away from the base of a tower. The angle of elevation of the top of the tower, we were given right there, is 57 degrees, 20 minutes. Okay, we also know that because this is a tower, and we're assuming that they plotted it correctly in level, and that's right there. We formed a right triangle, so that's 90 degrees there. I want to know the height of the tower. So I use this angle. From this angle, this is opposite, this is adjacent. So what formula uses opposite and adjacent? That's tangent. That's opposite. It's adjacent. So it's tangent is the only one I can use. So it's tan of 56 degrees, 20 minutes equals x over 135, so I'd multiply by 135 on both sides to get x all by itself, which is approximately 210.5 feet. Now, you can write this as a decimal if you wanted to, and just do 20 divided by 60, which is a third, so it would be 57.33333 that you would plug in for tan. Or if you looked and hunted under your math key, you would find degrees and you'd find the minutes. They are there. So you could type it in as is if you wanted. That's my point. So either one will work out fine. Example 5. From the top of a building that overlooks an ocean, an observer watches a boat sailing. So here we go. We have the observer. We have the building. There's the ocean. And we have the person on top. The observer watches a boat sailing directly towards the building. If the observer is 100 feet above sea level, and if the angle of depression from the boat, let's see here, it's 100 feet above ground, there I am. Oh, angle of depression means down, is 25 degrees, and it changes to 40 degrees. So that's 25 degrees. From there to there is 40 degrees. What we're saying is if the boat, from what he first saw, it was at 25 degrees for an angle of depression, and now it's 40 degrees. During the period of observation, approximate the distance the boat traveled. Okay, so we have a triangle here, and we have another bigger triangle. That's what we're getting at, and we know the angle measures. We're trying to find that distance right there. So we know that we have a triangle here of 100. We know that the base is 90 degrees. And first one is if it's 100 from here to 100 from here to here. If this is 40 from here to here, to make another right angle, right? Because this would make a right angle. If that's 40, then the top is 50. And I need to find this. Then the other triangle is 100 degrees. But if that's 25, then this other angle down in here would be 65 degrees. Because it's 25. So that makes that, to make that an even 90 there. So keep that in mind. And that's why. So basically what we're finding is I'm going to find out this distance here. Then we're going to find this distance from here to here. So once I have those distances, I can just subtract it to find out how far the boat went in between. So to do so, opposite over adjacent for this. Opposite over adjacent for this, because that's all that we can use. So it's tangent of 50 equals x over 100. So I multiply by 100 on both sides to get roughly 119.18 from here to here. Then it's tangent of 65 equals y over 100. So I'd multiply by 100 on both sides to get 214.45. But that's from here to here. So to find that distance in the middle from these 2 points, remember, from here to here was 119. From here the whole way over was 214. To see that measure in between those two, how far they went, I subtract it. So 214.45 minus 119.18, I figure out that the distance that the boat traveled was about 95.27. And I will try to finish up here on 6.2 on right triangle trig when I come back.